Hello, my name is Tom, we are here at Gamechanger Audio, and this is the MOTOR Synth MKII. This is the very first video in an ongoing video series about the MOTOR Synth MKII, its features, things that you can do with it, and sounds that you can get out of it. As we will be releasing new videos, all of them will be added to a playlist that you can find a link to in the description below. We'll do a deep dive into all aspects of the MOTOR Synth in future videos. But in this one, I want to give you a quick overview of what this machine is and the main features of it. The MOTOR Synth is an electromechanical musical instrument that uses drone motors as the primary sound source, on which the further sound synthesis is based upon. You could argue that it's not a synthesizer at all, but a tone-generating device. And there is some truth to it because it is distantly related to tone wheel organs and electric guitar. It's not the acoustic sound of the motors that you hear, it's the electro-inductive signal coming from the motors and the magnetic pickups attached next to each motor. Furthermore, there is an optical disc attached to the shaft of each motor, and that disc resembles a vinyl. There are 3 grooves from the bottom side of the disc, with 3 different wave shapes, represented in gradient patterns that are read by optical sensors. And those optical waveforms are optical sine, optical sawtooth, and optical square wave. These gradient waveforms are read by infrared optical sensors and then turned into sound. Because of inherent imperfections in this mechanical system, the readout of each waveform is less than precise. The sine is not a true clean sine wave, it's somewhere between a triangle and a sine, and the other waveforms, sawtooth and square wave, also have imprecisions in them. However, we see these imperfections as desirable because they give a unique tone for further sound synthesis. And here is a quick sample of the raw output from the motors. The M symbol stands for the magnetic pickup output, followed by the optical square wave, optical sawtooth, and optical sine wave. So how do the motors produce a steady musical pitch? The machine controls the rotational speed of each motor so that the output matches a musical pitch you are triggering with this keypad or MIDI controller. One of the major differences to the tone wheel organ is that instead of having a tone wheel per pitch that you are about to play, you have these 8 motors that can play any note you wish, and they change their rotational speed very quickly. Every time you hear a pitch change, it means that a motor is changing its rotational speed. And you might be thinking that all of this quick jumping between the notes and octaves can cause a lot of tear for the motors and wear them out. But keep in mind that these motors were designed for flying drones where they have to carry weight and maneuver in the sky. Here, they're just spinning freely, without any friction applied. That means that these motors will practically last you a very, very long time. As you can hear, this instrument is polyphonic. The 8 DC motors are split between 2 motor voices. That means that each voice can perform up to 4 musical pitches at the same time. Each of the 4 motors belonging to one of the motor voices passes through an individual amp envelope controlled amplifier, then into a mixer, and then each voice goes through a paraphonic filter. However, it is also possible to set individual voices to duophonic and monophonic settings, allowing you to mix more than one motor per note, changing the fatness of the whole sound. Or you can even make the voices perform different parts instead of being layers to the same musical part, but more about that later. The amp envelopes, and for that matter filter and modulation envelopes, are each controlled with a single encoder. Push the encoder to access the amp envelope screen, and push the encoder again to jump between the envelope stages. Turn the encoder to change stage value. Only one encoder for controlling the whole envelope? Yes. Controlling the whole envelope with one encoder allows you to change the envelope type based on the musical task that you want to do, instead of having one envelope with a set of knobs on the front panel. An ADSR style envelope has become the default envelope type for many standalone synthesizers. However, there are many musical scenarios where other envelope types might make more sense than an ADSR envelope. For example, when playing with a sequencer or arpeggiator, the AD envelope is my default choice. My actual favorite envelope in this synthesizer is borrowed from modular synthesis, the looping AD envelope. Besides having control over the envelope type, you can also control the curve of each individual envelope stage, or all stages at the same time. If you're playing with a velocity-sensitive MIDI keyboard, you can change the velocity response of the envelope. And some of the envelope types even have hidden parameters that allow to change them into a multi-stage complex contour generators. When changing pitch, the motors need to rev up or rev down. And it happens so quickly that you don't hear it as a glide, but it is there. And it adds to the unique character of the motor synth. You can extend this effect by using acceleration, which determines how quickly a sound will reach its target pitch, and you can set the starting interval. The break, on the other hand, determines how quickly a sound will glide up or glide down once you release a key. The acceleration and brake, similarly to the amp envelope, is individual for each motor. Let's talk about the filter. The harmonically rich sound of the motors responds very well to distortion and filtering. The filter is where the signal path becomes paraphonic. 4 motors of each motor voice are mixed together and sent through one analog multi-mode filter. It's 2 analog filters, one for each motor voice. The filter modes are 4-pole low-pass filter, 2-pole bandpass filter and high-pass filter, and 4-pole all-pass filter for phasing sounds and much more. All modes are resonant and can self-oscillate, including the all-pass filter. Each filter has a powerful drive section and a fully featured envelope that modulates the cutoff frequency. Until now, I've been talking about the motor sounds only, but there is in fact a digital voice, or DCO, which consists of 4 digital oscillators that model analog oscillators. Besides the volume knob, the digital voice doesn't have an independent controls on the front panel like the motor voices do. It is because we see it as an additional feature. However, there is a dedicated screen for the digital voice where you can use the two screen encoders to control all aspects of it. Additionally, in some cases, like with the amp envelope or the acceleration and brake section, it is possible to temporarily take over the motor voice 1 controls and control the digital voice instead. The digital voice can be used as a completely separate third voice in the synthesizer, or it can be used as addition to the motor sound, for example by adding noise to the mix or some high-frequency content from a digital square wave oscillator. The signal path of the digital voice is the same as with the motor voices. It also passes through a filter, but here it is a digital filter which models the analog filters both in features and sound. The digital voice sounds much more traditional when compared to the motor voices. However, it does have some wave shaping possibilities that are simply not there with the wave shapes printed on optical discs, like pulse width modulation and wave folding. I already mentioned the screen when talking about the digital voice, so let's look at it a bit more. The main performance controls are on the front panel, but there is a myriad of parameters that are less likely to be used during a performance, and those can be accessed through various screens and controlled with the two screen encoders. The encoders change their function depending on which screen is active. In the example of the envelopes, it is possible to change the envelope type using the right screen encoder. You can always exit to the main screen, which features an oscilloscope which monitors the main output of the motor synth, and it shows the note values of the performance keypad. The 8-button keypad with dedicated forward-pitch encoders is the central element of the motor synth's performance interface. You can of course play the motor synth using a MIDI controller or a CV source, but it is a lot of fun to play with these tiny built-in keys. Each key is tuned to a certain pitch, and in the basic 4-note polyphony setup, one key will trigger one motor in each motor voice and one digital oscillator. All keys can be tuned to any note in any octave or any frequency between the notes. This means that you can play with Western scales and microtonal setups equally well. Alternatively, it is possible to load one of the pre-programmed scales. The best part is that tuning doesn't necessarily have to be part of the setup process. It can also be part of the performance, especially when the keys are put in the latching mode, turning the motor synth into a drone machine. There are two rhythmical performance tools, the Arpeggiator and Sequencer. Let's start with the Arpeggiator. The Arpeggiator arpeggiates between the notes that are played with the keypad and MIDI controllers. It is a fully featured arpeggiator with play direction, time division, gate length, swing, note repeats, maximum pattern length, accents, and octave shifting. It is also possible to edit the arpeggiator rhythm pattern independently from the notes being played. You can change step parameters like velocity, ratcheting, and repeat. the arpeggiator can easily roam into sequencer territory. It works tremendously well for live performances and jamming. The sequencer, on the other hand, is better for composed parts. The sequencer offers even more step parameters to be edited. For example, individual gate lengths, glide, micro-timing for each step, probability, and step repeats. When programming sequences or editing arpeggiated rhythm pattern, the keys change their functionality from musical notes to step selection, and the pitch encoders allow you to edit various step parameters. Complex and at the same time rewarding aspects of the performance interface is the ability to assign different controllers to individual voices. Instead of using voices as layers of the same musical part, you can use them to produce individual parts on their own. In this next example, I have set up the Motor Voice 2 to be triggered by the sequencer producing a bass part. The digital voice is assigned to the keypad and arpeggiator, and the Motor Voice 1 doesn't respond to any of those controllers. Instead, it is controlled with a MIDI keyboard, producing a lead line. This is just one example of how the voices can be used to produce 3 completely independent parts, but numerous other setups are possible as well. There are 2 performance features related to the whole front panel. The first one is the motion record. Hit the record button and turn the knobs. Each knob will be assigned to one of the 8 available motion record lanes. You can record the knob movement and later alter it by changing the playback speed and direction. The best part is that the key presses can be recorded as well, turning the motion record engine into a performance looper. The second feature is the clutch key. As long as the clutch key is pressed down, all parameter changes are saved in a temporary buffer. And as soon as you release the key, all changes are applied simultaneously. This allows you to perform perfect sudden changes, including all parameters on the MOTOR Synth, without relying on presets. modulation section consists of 3 modulators, and the output of each can range from simple LFOs to complex envelopes and random voltages. The architecture of the modulation section is based upon modular synthesis. It is upon the performer to define inputs and outputs to complete the system. What I mean by that is that you can define the clock source for each modulator and the target parameter that it will modulate. The clock source can be various different things. It can be an arbitrary frequency. It can be the master tempo that you divide, or the frequency of last note played that you divide. Or it can be the clock of another modulator, allowing for cross-modulation between the modulators. And the modulators can be assigned to almost any parameter on the motor synth, regardless of it being a knob on the front panel or a parameter in various screens controlled with the screen encoders. In addition to a fully configurable modulation section, we felt that 2 modulation effects deserve their own spot on the front panel. The drift and detune knob modulates individual motor frequencies in 2 distinct ways. This allows you to dial in anything from subtle oscillator drift sounds to chorusing effects, all the way to wobbly madness. The cross-mod knob applies amplitude cross-modulation between the voices. You take the frequency of one of the voices and amplitude modulate the rest of them. This can produce anything from note-related tremolo effect all the way up to high-frequency metallic shrill effect. In my opinion, the MOTOR Synth is a feature-rich device which can produce a wide range of sounds. It can be a satisfying thing to learn the instrument, to develop muscle memory, and to find new ways of expressing yourself on the same device. However, sometimes it can be equally satisfying to rely on chance and see what you can make out of it. This is where the random generator comes in. The random generator can instantly produce random parameter values, coming up with a completely new sound. A fun thing to do is hit random, 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 random until you find a sound that you think you could use. Then you can tweak that sound, and if you come up with something really good, you can save it as a preset. The random generator can also generate random sequence patterns and arpeggiator rhythm patterns, and those can be saved into projects, which also save the system settings. Because of the random nature of this process, some of these new sounds will be unusable. That's why you can limit the randomization amount for each individual part of the synthesis. And as the last thing, I want to cover the inputs and outputs of the MOTOR Synth. And let's start with the input. The input can be used in several different ways, and the most exciting one, I guess, is the vocoder. There is a built-in digital 16-band vocoder that uses the output of the MOTOR Synth as the carrier and the input signal, your voice or another instrument, as the modulator. The most practical use of the input jack, at least for me personally, is to use the input envelope follower. It can duck or gate the output from the MOTOR Synth dependent on the input playing dynamics. So if you have a kick coming from your drum machine, you can produce a pumping bass sound without any external gear. Input envelope follower can also generate trigger signals from the input transients, and that trigger can advance the sequencer or arpeggiator to the next step instead of the internal clock. It can be a lot of fun when playing with other people, and we will get to that in a separate video. The main output of the MOTOR Synth is a single jack output, and it can be configured to send a mono signal with all of the voices mixed together, or as a dual mono output with each motor voice on its own channel and with several different digital voice routing options. The MIDI inputs and outputs allow the MOTOR Synth to be fully controlled with external MIDI gear, or you can sync other gear to the MOTOR Synth. The 3 analog CV inputs and 3 trigger inputs can be assigned to nearly any parameter on a MOTOR Synth, similar to the modulation section. The send and return mini jacks allow you to send each motor voice to the external gear and back before the filter. And the USB slot is for accessing presets and projects on the SD card or for MIDI connectivity. This was a quick introduction in the main features of the MOTOR Synth MKII. We'll explore each of them and few more that I didn't mention now in separate videos, so be sure to check the full playlist.